how Grakn and Grakl compares to the semantic web technologies, you're in the right place, and we're excited to be having this conversation. Grakn Labs Online, these webinars specifically, came out of, it came out of the situation we're all dealing with COVID-19. We all were stuck inside, and travel plans were all canceled. And, you know, Tomas and I usually spend this time going out and meeting all of you in your local cities, being able to chat face to face over a beer or dinner, or you know, post these presentations. And we really missed this opportunity to engage with all of you in an intimate one-on-one way. So the closest thing we could come to was bringing all of our events that we would have run live and bring them online. And then we continued to add in new events as we moved through the summer. Today, we're obviously talking about comparing Grakn and Grakl to the semantic web. We also do a comparison on SQL to Grakl, our query language, as well as a bi-weekly introduction to Grakn, introduction to knowledge graphs that Tomas and I host on Thursday evenings. We will be on tomorrow evening, and then we skip a week and we'll be back the following week. And that really is meant to be your check-in, where you can bring along folks that are brand new. You can bring your questions as you're working through projects, as you're working through your evaluation or discovery of Grakn. That's really meant to be your stake in the ground. Every 2 weeks, you can come and say hello to us anytime. The other piece to our community that we have shifted is we're now on Discord. And Discord has really been an amazing hub for our community, in that all of us live now in one server. So there's no issues switching back and forth from internal to our community. We are now, our internal teams, Tomas and I, as well as all the engineers, we're all there on Discord. It's an excellent chance for not only for you to share your questions, share your feedback, your ideas with the rest of the community, but also engage our internal team directly. So we encourage you to DM us, say hello. Tomas, you're at Tomas, I'm at Daniel, and you can join our Discord server by using your phone camera, hold that up to the QR code, and you can find the registration link right there. So I mentioned some of the other events that we're doing. You can find the full schedule on the left-hand side. Again, hold your phone camera up to the QR code. And then on the right-hand side is our YouTube channel. And our YouTube channel is really meant to be the inspiration hub. It's where our community shares their projects after presenting to our community in one of these webinars. All of our global conference sessions are on in the playlist there as well. You can see everything from applications in expert systems to cybersecurity, to native tax applicions, NLP, robotics, and a whole host of things in between. But definitely check that out. Use that as a sort of jumping off point if you're looking for inspiration. Now for quick logistics on today. So we host the Q&A for our webinars a little differently than you might expect and might have seen in other communities. And we do this because we want to share knowledge. We want to share knowledge across both our communities as well as yours. So what we ask is that you post your questions to Twitter, tagging at Grakn Labs, and today being a conversation around the semantic web, hashtag RDF. We'll then answer your question directly in this session here. We'll take that little video clip and post it back to your original question on Twitter, and that way everybody can take advantage of this knowledge sharing. So we thank you and appreciate your engagement there. I'm going to be running things in the background, so if you have any technical issues, please feel free to DM me. Again, post your questions to Twitter. If you don't have a Twitter account, please drop them into the QA. And otherwise, enjoy the session, and please be ready to throw us feedback at the end. We will allow for a little open mic time, I think, and we'll hear what you have to say. So without further ado, Tomas, dive in, and I will see you on the other side.
Thank you. Thank you, and welcome everyone for wanting to spend a couple of, to spend an hour with us today and to talk about Grakn, specifically in relation to the semantic web. Now, before we before diving in deep into the actual presentation, there's a couple of things to say. So the topic for today is comparing Grakn to the semantic web standards. Now, inherently, I want to say this as a sort of a disclaimer. The comparison isn't particularly fair because we're comparing literally a set of standards to a technology implementation. And inherently, that's kind of comparing apples to oranges. What's more, the semantic web as its vision is very different to what Grakn tries to do. For example, so the semantic web is built for the web. Grakn is not built for the web. So there's a lot of problems with this comparison in that we're comparing two technologies that are quite different in what they're trying to do. So I want to start off with that caveat. Nonetheless, there is still a lot to be said about both the semantic web and how it compares to Grakn. And it's those differences and some similarities as well that we're going to be covering. Mainly because a lot of people ask us to compare how they both compare and relate. So without further ado, let's dive in. So we're going to look at a couple of things. And we're going to start, of course, with a high-level comparison of what's the vision and how does the stack in semantic web compare to Grakn. And there's 5 different standards that we're going to be looking at. We're going to look at RDF, we're going to look at Sparkle, RDFS, OWL, and a little bit of Shackle. So we don't have time, simply we don't have time to go in depth in any of those. So we're going to merely touch the surface of all of these standards. We're also not going to look at any specific implementation, and there may be some new libraries that come out that we won't be covering. So please bear that in mind, but hopefully this will be a good starting point to understand how to think between the two. So for anyone familiar with the semantic web, I think this slide is well known. This is the semantic web stack as dreamt up by in the early days. And now today, where we sit, when it comes to building the actual standards, is building out this part of the stack. So the querying, the syntax, the taxonomies, the data interject, identifiers, ontologies, and specifically using these technologies: Sparkle, OWL, RDFS, RDF, XML, and URIs. Now, one of the key things about the semantic web stack is that for each one of these standards, there's a myriad of implementation, and that in itself brings a lot of complexity with it, simply because the standard may be beautiful, the standard may work, but there's so many different implementations of the standard that it becomes quite difficult to see the woods through the tree, if that's the right way of saying
see the forest through the trees.
See the forest through the trees. Thank you, Daniel. I'm a non-native English speaker. Please excuse me. And basically, the difficulty is in there simply that there's so many different standards that it's just hard to learn them all, and so the implementations of all the different standards. So, and this is the key point when we start comparing Grakn, is that Grakn is just one technology, and sure, it cannot do everything that OWL does. It can't do everything that all of them do. But at the surface level, for the most important things you need to be able to do to build software, that's what we put in Grakn. And so, in a sense, Grakn provides just one technology as a higher level abstraction over semantic web technologies. And that's really important. So with that in mind, I want you to look at each of these ones as RDF doesn't completely compare to Grakn. And actually, there's something interesting we can say about that specifically. But each one does Grakn does one specific aspect of each of these standards. So let's start with RDF. Now, an RDF triple, of course, that's a basic subject, predicate, object. And RDF, to be honest, and something that gets forgotten, RDF is just the data exchange format. In a sense, you can use different technologies, not only native triple stores to represent RDF data. Grakn, technically, in that sense, can also be a triple store. So the equivalent representation in Grakn, the data model, instead of working with triples in Grakn is the entity relationship model, crudely represented here on the right. But basically, we're working with entities, relations, and attributes. So those are the first class citizens of the model. And I hope that starts to kind of paint a picture in that the native data model in Grakn is higher level than a triple, because a triple is lower level, especially because we're dealing with in Grakn with the roles, and roles contextualize how something, which and a thing can be an entity, a relation, or an attribute, how something relates in a specific relation. That's how and why we use roles. Now let's look at an example. So let's say Peter knows Aunt May, Peter Parker. It's a Spider-Man reference. Are you a Spider-Man fan?
Yeah, a bit.
Good.
One kid that grew up in the 90s is a Spider-Man fan.
Yeah, that is true. So let's say Peter Parker knows Aunt May. Now, in RDF, we would say we've got a triple, a person knows another person, specifically a person with a name and another person with another name, Peter Parker and Aunt May. We may also specify the right namespace. In this case, the friend of a friend, key space, the namespace. Now, in Grakn, instead of using triples, the equivalent in Grakn in this case would be the implementation of a concept level entity relationship model. And here, the way we would do that is we have an entity, a person entity, two persons entities. They have attributes attached to them. So a person has a name attribute and another person has also a name attribute, and they are connected through a knows relation. So instead of creating a triple, here what we say is that there's an entity that has a relation called knows with another person. And another important thing to keep in mind is that because Grakn isn't built for the web, Grakn doesn't use any public namespaces. And that's something important. There's ways around if you do want to use a public namespace, but natively Grakn won't support that, and that's by design. So let's look at some code. Now, before anyone says anything, we're also going to look at Turtle because XML is slightly harder to read. But let's start with XML. So this specific triple, so Peter Parker knows Aunt May would look like this. So we specify the URI at the top, and then we've got the triple that we represent in XML. In Grakn, we would say it like this. We would define, first we've got these two variable names, these variables. So $P is a person, has name Peter Parker. So a person has a name, so an entity type person has an attribute with a value, Peter Parker. And then there's another person, that's why we have a different variable name here, that has a name, another name, Aunt May. And then we say that $P and $P2 are connected to each other through a knows relation. And that's effectively how we would represent what we just showed. Now, bear in mind here, we're not specifying the roles yet. That'll come later to keep things simple. And another thing to mention is that if you really need to, you can add URIs as attributes to any resource in Grakn or anything. So even an attribute can have an attribute. So if you need to add a URI, you can add that. It's just not it's not built for that. But again, if necessary, because you're importing some RDF data, then yes, you could do that theoretically. Now, the other important concept in Grakn that is different to most RDF, or let's say to the basic RDF that most of us use, is the fact that Grakn builds on a hypergraph. And so natively in Grakn, we work with hyperrelations. And what that means is that while in RDF, an edge is just a pair of vertices, that's a directional edge. A hyperedge is a set of vertices. So we effectively can have n number of vertices in one edge. In practice, that means that we can have relations that look like this. So we can say a ternary relation with 3 role players, a buyer, a seller, and a product, and a purchase. And specifically in Grakn, that means we can also have nested relations. So we can have relations in other relations. So here we've got a marriage between 2 spouses, but now we're localizing that marriage in a city. And to localize the marriage, we connect the marriage relation through a located relation to a city. And another example where we have a very unfortunate marriage. Alice was married to Bob, as we can tell in the relation here on the right, and diamond shapes denote relations. So Bob played the husband and Alice played the wife, but then they got divorced. And the petitioner was Alice, so Alice petitioned for that divorce, and the respondent was Bob. But then, and so we call this a divorce filing relation, where the marriage here, we've got a nested relation in a three-way relation. So the marriage plays the role, and the relation plays a role of the certified relation in a divorce filing relation. Now, how would we try and do this in RDF? Now, there's multiple ways that we could go about doing this, but we took one example. Now, we would start with saying Bob is married to Alice. There's a divorce with a certain divorce type, divorce filing. There's two more predicates that we add, and then we also define the marriage being the marriage having a bunch of other more predicate statements as well. And without getting too deep into this, the point, just the only point that we're trying to make here is that the concept, the construct of a hyper relation in Grakn is a first-class citizen. And that means that in order to create hyper relations, we don't have to reify our data, for example. And that's something that's really important in the way we believe you should model and work with Grakn. So let's look at other types of relations. So here we've got an example of a higher order relation. And the statement that we want to represent is the following. We say J.K. Rowling wrote Harry Potter. Now in Turtle, we would say, we've got two namespaces here. We say Harry Potter, author J.K. Rowling. So we've got this predicate, this triple here, Harry Potter, author J.K. Rowling. Now in Grakn, if we were to try and represent the equivalent, would be like this. Sorry, actually, I misspoke. Let's say we want to make a statement about that statement. And so we're saying J.K. Rowling wrote Harry Potter in the year 2000. So we're making a statement about the fact that she wrote Harry Potter. So we would say, we would write three triples. We've got author, J.K. Rowling, title, and publication date. Now, effectively, what we see on the right here, we're effectively reifying how the number of triples that we're making in order to make that statement. Now, the fact we have to do this because we can't actually make a statement about a statement natively in RDF. I think there's some libraries available to extend it, but if we just look at the basic that most people use, it's really hard to do it. Now in Grakn, the way we would go about doing it. So let's first start with the sentence, just J.K. Rowling wrote Harry Potter. So we're not still making a statement about the statement. So we've got an authorship relation between a book and within a person, that's the author of that book. Now, as we can see here in the code here, we say $A is a person with the name J.K. Rowling. There's also a book, Harry Potter, and then both are connected through an authorship relation. So as we can see here, J.K. Rowling plays the role of author, and the book plays the role of publication in an authorship relation. Now, let's make a statement about that authorship relation. So she wrote it in the year 2000. To do that, the only thing we do here is we say the relation now has an attribute. So we add an attribute to that particular relation. So now this authorship relation has a date. And that's why we say has date 2000 in this case. So what we're seeing here is we're adding an attribute to a relation. Now, this is also a question that we get quite often, and this is a short slide, but it's worth mentioning. The notion of blank nodes doesn't quite translate to Grakn the reason why you would have a blank node is because you may not be able to refer to anything. You don't want to refer to a specific thing because you don't have that information. Let's say simply because you're working with incomplete data from the web. And this is again where there's a kind of a conflict when we're comparing Grakn to the semantic web, in that you're working with the semantic web has tools, has features available to work with incomplete data, which is what you get when you're working with web data, versus Grakn, which is a closed system, which always assume that whatever data is in there is always complete. So let's answer the question of how to think of blank nodes in a Grakn context with the sentence right here. So we're saying Harry Potter was inspired by a man who lives in England. So we've got two triples here. We're saying, so Harry Potter name, Harry Potter. We're saying then that Harry Potter has inspiration by a man, but we don't know who the man is. So that's why we're leaving it blank. And he lives in England. So now the only equivalent way of, but again, it's not exactly equivalent, but let's say we don't know, if we don't have the information of a particular node that we want to refer to, whether it's a subject or an object. The way we could do it in Grakn is by simply not giving any information for that man, because as you can see here, we're just defining, there's a book with the name Harry Potter, and then for this $m, so this variable m, we're not adding any filters. So we're just saying, give me any man, any of type man. Now we could also just say, give me $m, and if you just ask for $m, it's also going to check for any type, really. It may be a relation even, or an attribute, not just an entity. And as you can see here, we push then that $m into this relation with $b, which is the book. And that relation we call an inspiration relation, before then connecting that inspiration, connecting the man also to a lives in relation in that second relation right here, where the $L is connected to an entity of location with the name of England. Or another thing is we query for a thing without a key URI, which effectively would be the equivalent of that we don't know the URI in RDF if we're looking for a blank node. So now let's look at Sparkle. And something to say again beforehand, Sparkle is effectively a query engine that allows you to query and traverse data, graph-shaped data from our RDF type data. But again, Sparkle was built to work on federated data. So it's built to specify your namespaces, then query for your data across those namespaces. Again, Grakn works quite differently in that it's not just a query engine, so it does much more than just Sparkle, but it's not supposed to work over federated data unless you have loaded that data into Grakn. That's something really important to keep in mind, because those are kind of paradigm shifts, or well, not paradigm shifts, but just mentality shifts if you are used to working with federated data in a semantic web context. So let's insert some data. So we've got the sentence here: a book with the title new book and creator a and other. It's supposed to be a pun. As you can tell, it's supposed to say another. So now in Sparkle, how do we insert? Now, Sparkle very much looks like SQL. So anyone familiar with SQL should somewhat be familiar with Sparkle, other than the paradigms that are quite different to SQL, of course. But here we're saying insert data, there's a title and there's a creator, and there's some URIs as well. Now in Grakn, and bear in mind, we're using the keyword insert data to begin with. In Grakn, to insert, similarly, we start first with the keyword insert. So insert defines, we want to insert it. It declares that Grakn should ready to catch any data that you're pushing into it. So, and then you declare the data that you want to insert. So here we say $B. So again, $B is just a variable name. $B is a book. So a book here is an entity type book that has a title, a new book. So here we've got a string that is the value of this attribute title. And also there's another attribute, the entity type creator, and the value of that attribute name is an other. And effectively this is the same, but bear in mind here, whilst in Sparkle we're effectively inserting a triple, in Grakn we would think not in the sense of inserting a triple, we would think of it as inserting an entity with an attribute. Now let's query for data. So now Grakn and RDF, your RDF store, we've ingested some data. How do we now query for it? So let's take this question. Who are all the persons that Adam Smith knows? Let's look at a Sparkle. So in Sparkle, what we see here, we're saying we've got this person here, which is the one we select. This is what we want to be returned. And the filters are just saying there's family name, there's a given name, and finally there's a whom. This, which we don't know, and this is the one that, sorry, I misspoke, this is the one that we select. So we select the variable whom, and simply because person here, given these filters, is now connected to whom. So we now filter the data and we're specifically interested in this one. So that's effectively the traversal that we're interested in. In Grakn, we would first start, the equivalent of the select query here is the match query in Grakn. So unlike an insert statement, match is the equivalent of saying, match me some data and give it back to me. So here we see $P, which is a variable name. $P is a person, has family name Smith, has given name Adam. So similar to what we did just now before in the previous slide, we're inserting a person with two attributes, and then we're connecting them together. So we're saying $P is connected to $P2. We're specifying also the relation type, which is of type knows. And bear in mind here, similar to select whom, we're specifically querying for $P2. So that's why we say get $P2. Let's look at a more complex query. Give me all the directors that James Dean played in, where also a woman played a role, and that woman played in a movie directed by John Ford. So it's a bit of a mouthful, but I hope you can follow. So how do we write this in Sparkle? So there's a bunch of traversals that we're doing here, but effectively we're saying this actor is of type man, has the name James Dean, played in this movie. There's also an actress that played in the movie. There's the actress of type woman, and the actress played in another movie. We also have John Ford, which is of type man, and played in a movie. And then finally we say another movie is directed by John Ford. And what we select is director and movie. So again, we've got a traversal that we're traversing through and selecting some of that data using the filters that we use. In Grakn, now this is where it's interesting because we would have modeled the data quite different or slightly differently than if you were to use RDF, because as you can see here, we're asking, give me the man here with the name James Dean. Then there's a woman, but then what I'm saying is that there's a three-way relation between an actor, an actress, and a casted movie. $P, $W, and $M in a relation that we're calling a casting relation. And then we're saying that the woman is connected to $M2, so to this another movie in a casting relation. And then finally, we're saying that there's a man, John Ford, and then $D is connected to $M2 in a directorship relation. And then we're fetching get $D and $M, which we've defined. So now the reason why this is different is because, well, in Sparkle we would be making a traversal. In Grakn instead, rather than thinking of it as a traversal, firstly we're asking for a three-way relation. That's why it's quite a different type of query. We think instead of what are the connections between the entities and the relations. So that's been quite a mouthful already. I hope that's been easy to follow so far. But let's also look at RDFS. So now RDFS, for those unfamiliar, I'm assuming you are not, but our RDFS is just effectively a set of ontological constructs on top of RDF to have some sort of basic schema. So let's say we're creating a hierarchy, and we're saying that a horse is a subtype or a subclass of an animal. In XML here, we would say it like this. We would say there's this class is animal, which is of subclass. Sorry, there's this horse that's of subclass animal. And in Grakn, we would use the keyword sub. So having defined the animal entity, we can now define the subtype horse as being a subtype of an animal. But let's say we extend the model, and now there's also relations that have subtypes. So we're saying that an employment has a subtype, specifically a part-time employment. On the left would be the XML code that we would write, and specifically, if we look at the part here on the left, we're saying that there's a property, a part-time employment, which is this one here, which is a sub property of employment, which is this one right here. In Grakn, we would, again, same as with an entity, we would use the keyword sub. So we say employment is a relation or sub-relation, and then we say part-time employment, sub-employment. So now we've created a subtype of employment, specifically a part-time employment. And there's an important thing to be said here about multiple inheritance, because this is a very crucial design decision in Grakn, in that the Grakn doesn't support multiple inheritance, and that's by design, not by fault. And the reason is because we prefer composition instead of inheritance. So let me explain that by an example. So let's take this what we're seeing here now. So if we've got if we've got an employer, that's a company, and we've got and also an employer that's a subclass of a government. Well, in Turtle we would say something like this. As you can see, employer, both this one class is the subtype, the subclass of both company and government. In Grakn instead, so rather than thinking of multiple or assigning classes to other classes as subclasses, we would create roles. So you assign a role to denote the context on which that type behaves in the context of that relation. And we simply do that by using the keywords plays and relates. So plays is how a particular entity or any type actually is contextualized in the context of our relation. So here we say, a company would play the role of employer, government can play the role of employer in an employment relation. So an employment as a relation would relate now to that employer relation. So instead of creating an entity called employer, we think it's a role in the context of an employment relation. So to summarize, Grakn supports single type inheritance, as we saw, but Grakn prefers composition over inheritance. And the way we do that is through roles, and specifically multiple type inheritance. So now let's look at RDFS domain and RDFS range. Now again, both these structures are really difficult to translate directly in Grakn, because domain and range are really shine, particularly when you've got incomplete data coming from the web, which again is not a use case for Grakn. Nonetheless, let's look at how we could use them in Grakn, or how they would translate. So here, let's take this domain statement. So we say that given this property published on, its domain would be of class published book. So all the domains here would be of this class. The way we could do that in Grakn, that's one approach here, is again by assigning a role to this specific entity. So what we say here, and here we're using a rule in Grakn, which is part of the schema. we're saying $B has a published date, $PD. So $PD is just the value of the attribute. And then this, and if this entity has that attribute, then we assign it this role. We assign it saying that there's a published book to that $B in a publishing relation. And for the range, let's say that given a has brother property or property here, the range should all be male. So they should all be of class male. In Grakn, we could do very simply by saying that if any entity plays the role of brother in a siblingship relation, then we simply say the $P has gender male. So now every entity in $P will have a gender of male. And that's how we could go about doing it. Now, let's take a more complex example. So let's say if we have a vessel, let's say the vessel is of class departing vessel, which has the property next departure specified. We could state this. We could say vessel is of this type. Departing vessel is of is a class. Next departure is a property. Then we've got a Queen Elizabeth, which is a vessel, and Queen Elizabeth II has a next departure on March the 4th, 2010. Now, with RDFS domain, any vessel with next departure will be inferred to be a departing vessel. So, given this domain here, any member, any vessel in this next departure will be of this type, of this class, departing vessel. So, in this triple right here, Queen Elizabeth II would be of member departing vessel class. Now, in Grakn, we would write a rule that connects any entity with a next departure attribute to the departing vessel role. So we can have a rule here that says $S has next departure $ND. So again, this is just assigning a variable to the value of that attribute. And if this is true, so if this particular variable has this attribute, then it is assigned the role of departing vessel in a departure relation. So given this, if we now insert this data, we say that if $S is a vessel has name Queen Elizabeth II with this next departure date, then Grakn will infer that Queen Elizabeth II plays the role departing vessel, this one here, in a departure relation. Okay, so far so good. We've done an RDFS. We've reached OWL. Okay, let's now, some of the previous caveats that I gave before, OWL being really built for the web and being so rich in all the different families that exist with all its history. Of course, Grakn doesn't try to be a different or a replacement of OWL. In fact, and also both do quite different reasonings, type of reasonings. Grakn specific does rule-based reasoning, and OWL is more an ontological reasoner. So both are quite different. But because OWL is different, is popular, we're going to look at it. And we're not going to look at it in complete detail, but we're just going to look at a couple of restrictions and axioms and see how that would be implemented in Grakn. So, given this restriction, all values from, if the range of has parents with person animal classes can only have person parents or animal parents values. So effectively, we're saying only animals can only have animal parents and people can only have people parents, which makes sense, I think, unless something really bad is going on. So the first restriction, we're saying that given this person, which is an OWL, which is a class, has a restriction that on this property has parents, all the values need to be person. And the same effective for animal, but rather than saying all values need to come from person, they need to come from animal. Now in Grakn, there is a direct equivalent in Grakn. Instead, we can actually implement this restriction in the schema. So remember, Grakn implements a schema restriction on write. So there's logical verification every time you write into the database, so you can actually restrict what type of data can exist. So what this means is that, so we define a parentship as a relation, and we also chose to define two subtypes of parentship relations. So a person parentship and an animal parentship. And here we see that a person parentship relates to a person child and a person parent. And similarly, an animal parentship relates to an animal child and an animal parent. And as you can see now, having defined these, we can now say that a person can only play the role of person child in a person parentship relation. So now a person cannot have a parentship relation with an animal. That is simply not possible now. And similarly, an animal cannot be related to a person. So we effectively implemented the restriction from Al in Grakn. And then we've got transitive properties. So if A is connected to B and B is connected to C, then A should be also connected to C. Now, how do we do a transitive property in Grakn? So given this example here, so if King's Cross is located in London, and if London is located in the UK, and if the UK is located in Europe, in Grakn we would say, if A is, we create a rule. So we would say that if A is connected to B and B is connected to C, then A should be connected to C. So with this rule, if we now insert A to B and B to C here, so London, UK, and Europe, if A now is connected to B and B is connected to C, the query now, this query will return the right data. So match $B is a continent, has in Europe, located B, and then if you fetch for A, because this is B is Europe, you get for A, you're not only going to get London, sorry, UK, you're also going to get London, and London will be a transitive relation. And then we have equivalent properties. This is where two properties have the same property extension. So quite simply, an equivalent borrows property is the equivalent property of a checkdown property. And in Grakn, again, this is quite simple. We would again just write a rule that says that given if X and Y are connected through a certain type of relation, as example borrowing, then they should also be connected through a relation called checked out. That will be the almost literally the exact equivalent. And here we've got red wines should have the color red property. So there's an entity called red wine that has that property. Now, we want to say that every red wine, so everything of class red wine, as we can see here, red wine, should have the color red property. Again, this is fairly easy to do in a rule in Grakn. We just say when $W is the red wine, so if this variable name is of type red wine, then $W has color red. So we've covered some parts of OWL, and now let's look at some shackle as well. And we won't say much about shackle, but what is important is to realize that the schema restrictions that Grakn offers are to some extent also covered by shackle, which you don't get with any of the other standards. And so let's say we want to restrict a person to work for a company, and we want to restrict the company to have a name attribute of data type string. Now in shackle, we could say something like this. We've got a person that works for a company. And a company can only have the name can only be of data type string. So in Grakn, we would quite simply, again, we would use the schema to represent these verification, these restrictions, by simply saying that a person can only play the role of employee. And by having only declared it as playing the role of employee, it can only relate to this employment relation, which satisfies a requirement on the left. And also we have this attribute here, name, that is of this value string. So to kind of wrap things together, there's a couple of things we would focus on when we think of Grakn. especially compared to semantic web. Now, the first is that Grakn reduces the complexity while maintaining a high degree of expressivity. Grakn provides a higher level abstraction for working with complex data. And finally, semantic web standards are built for the web, while Grakn works for closed world systems with private data. And the point is that Grakn wants to, especially if you're coming from the semantic web background, that Grakn provides you with one technology as a higher level abstraction over semantic web standards, as well as implementation, of course. So with that in mind, thank you so much for attending today.
Thank you as well, and thank you, Tomas. Well done as always. You can see on that nice little, the last slide there, from some of our the pictures from our previous webinars. So this is where I would love to open it up. If there's any feedback, any questions from the group here, I'm more than happy to bring you off mute and hear any thoughts, any sort of maybe curiosities that this sparked, but would love to hear from everybody and sort of open up the floor. So you just raise your hand, and I can bring you off of mute. Otherwise, Tomas, for the folks that are watching at home here, at what point would you say someone should consider Grakn if they've already started down the path of building a knowledge graph with semantic web technologies?
So from our point of view, we built Grakn because we think the balance between expressivity and maintainability of semantic web technologies is just, well, unsatisfactory. So we don't think most, especially if you still have a choice, most of our applications should not be built if you have a choice not to use the semantic web stack simply because of that balance, unless you're doing a very advanced academic project that needs to rely on the semantic web stack. There are some other edge cases where I think if you are working in a consortium with other partners and companies where everyone is leveraging certain standards and certain namespaces that are public, then perhaps it makes sense to stick around. But at the end of the day, you will face hurdles when it comes to that balance of how expressive is it, but how complex do you make it, and that's particularly true when it comes to scaling that up, not just in terms of volume and data and horizontally, but also in terms of scaling up the number of people that work on the project. Simply because it's hard to build a good team of semantic web experts. Right,
absolutely. So, and you went through obviously went through a number of very specific comparisons within each of the semantic web technologies. What will be like if I've already started sort of down the line and I want to begin playing around with Grakn, I want to begin evaluating Grakn's as an alternative, a solution for what I'm doing. What might be like one first step that you could take to sort of get started?
Well, I think so we try to provide a fairly useful quick start on dev.grakn.ai. That's kind of a phone calls example to get started working with Grakn initially. And from there onwards, there's different paths that one can go. But I think just kind of saying hi in the Discord channel is always is a very good idea to see who else is out there building something. Also just to kind of get to know our guys. We always want to know what people are using Grakn for, because otherwise we just sit here and just build a technology and we never really hear from anyone. Luckily, that's not true, and we do hear from a lot of people. But we encourage anyone to share whether they have ideas on how to use Grakn. Let's brainstorm together. Where we quite enjoy that.
Yeah, absolutely. And a quick shout out to again to our Discord server. It's really an amazing place for you to sort of poke around on a daily basis and interact with all of us. And I think to add on to your response there, given that you're maybe going from public namespaces to something that you're going to adopt for your closed world domain, rethinking the model first is a good approach of trying to more deeply understand Grakn and Grackle, and moving from the semantic web model that you've been using to Grakn.
Yeah, I think that is right. Yeah.
So if anybody has any thoughts, any feedback, please do raise your hand. Otherwise, we will say goodbye for now. And again, as I mentioned, we're back tomorrow evening, 6:30 London time. Tomas and I are going to go through our introduction to knowledge graphs with Grakn and Grakl. We'll take a bunch of questions from the community, hear updates from those that are working on projects. So we encourage everybody to attend here. Let's just see here in the chat. So Glenn asks, expressivity, great aim. Is there a tool for expressing in a more diagrammatic form?
I'm not sure if you mean by diagrammatic form to have a like visual form, visual way of representing it. Then we can use Workbase for that. But it'd be good to know exactly what you mean by diagrammatic, Glenn. I'm assuming it's visual. And for that, we've got Workbase, which is the visualization tool, which we didn't cover today, but yeah. Yes, visual. Yeah. So yeah, if you use Workbase, you can effectively see your schema as a graph. So if you go to Grakn and you download Workbase, which is also open source, Workbase is like an IDE to visualize our data, work with our data, and that also has a schema editor. It's a button on the top left corner that you need to click to get to the schema editor from the visualizer, which is to visualize data, which is not the same as the schema.
And you'll get a demo in Workbase tomorrow as well, so you can see that live in the digital flesh. Okay, thank you everyone. Have a great evening, afternoon, morning, depending on where you're calling in from in the world. From Tomas and I, thank you so much, and we will see you soon. Bye, everybody.
Bye.